Just as we promised, we will test the charging performance of the other Apple 35W charger. So here it comes. But if you haven't seen the previous video, you can click the upper right corner to take a look. And what we're gonna test today is the traditional version of the Apple 35W charger. And also, let's briefly introduce this charger. If you want to see the specific test, you can choose the different chapters below. Open the box. Just like the compact 35W charger, there is no cable inside. This charger continues the design of traditional Apple chargers, but those two USB-C ports are different from other Apple chargers. Unlike the compact 35W charger, the input prongs can be detached. You can easily replace different input prongs. The specs info is on the side. Model is A2676. It can support wide range input of 100 to 240 volts, 50 or 60 Hz, and output of 20 volts, 1.75 amp, 15 volts, 2.33 amp, 9 volts, 3 amp, 5 volts, 3 amp. Manufactured by Flextronics Power. The size is about 56 by 56 by 28 mm, and the weight is about 116 grams. Compared to the old 35W charger, the size is almost the same, but it has an additional USB-C port. The PowerZ KM002C shows it only supports PD 3.0, and full fixed PDOs are 5 volts, 3 amp, 9 volts, 3 amp, 15 volts, 2.33 amp, and 20 volts, 1.75 amp. Then let's test its charging compatibility. It can reach 33.5 watts when only charging the MacBook and can be perfectly compatible with iPhone and AirPods. We also briefly tested the dual output strategy in the previous video. You can click the upper right corner to take a look. We're working on another video to discuss this issue in detail. Here are the compatibility test results of this charger. It can charge the switch but cannot activate TV mode. The power of Android phones is mostly between 15 to 25 watts. You can pause to check it. Since the M2 MacBook Air is still unavailable, we have to use this charger to charge the M1 MacBook Air fully. The charging process is roughly divided into 4 parts with a maximum power of 33.09 watts. It takes 2 hours and 25 minutes to charge fully. We also found it can reach 30% in half an hour and 61% in an hour, almost the same as the other 35W charger. Next, let's test the power consumption when plugged in. The no-load power consumption of the charger at 220 volts, 50 Hz is 0.097 watts, which is about 0.84 kWh in 1 year. And the no-load power consumption at 110 volts, 60 Hz is 0.066 watts, which is about 0.57 kWh in 1 year. That's pretty low. The charger is essentially a conversion device, so energy will be lost in the process of converting AC to DC. So here is the conversion efficiency test of this charger. The conversion efficiency varies from 84.65% to 92.65% at 220 volts, 50 Hz. The conversion efficiency varies from 85.47% to 92.24% at 110 volts, 60 Hz. That is higher than most PD chargers, and higher conversion efficiency means lower temperature, which users can feel intuitively. Nowadays, most chargers adopt switching power supply, which means the output current from the transformer needs to be rectified and filtered. Therefore, there will be ripples in the output current. The lower ripple means better quality. Firstly, let's see the 220 volts, 50 Hz. When the output is 5 volts, 0 amp, the highest ripple is 48 mV peak-to-peak. When the output is 9 volts, 0 amp, the lowest ripple is 24 mV peak-to-peak. Then switch to the 110 volts, 60 Hz. When the output is 5 volts, 0 amp, the highest ripple is 48 mV peak-to-peak. When the output is 9 volts, 0 amp, the lowest ripple is 16 mV peak-to-peak. Then let's see the difference when loaded. Firstly, let's see the 220 volts, 50 Hz. When the output is 15 volts, 20 volts, and 9 volts, 3 amp, the highest ripple is 32 mV peak-to-peak. When the output is 5 volts, 2 amp, 5 volts, 3 amp, and 9 volts, 2 amp, the lowest ripple is 16 mV peak-to-peak. Then switch to the 110 volts, 60 Hz. When the output is 15 volts, 2.33 amp, the highest ripple is 48 millivolts peak-to-peak. When the output is 5 volts, 2 amp or 3 amp, the lowest ripple is 60 millivolts peak-to-peak. We found the highest ripple is still under 50 millivolts peak-to-peak, which means the output quality is excellent. As we mentioned, in the process of converting AC to DC, energy will be converted into heat. We'll put it into a 25 degrees Celsius thermal tank throughout the test and let it run for an hour at 20 volts, 1.75 amp, 35 watts. And firstly, the maximum temperature on two sides of 49.5 degrees Celsius and 50.3 degrees Celsius under 220 volts, 50 Hz. Then the maximum temperature on two sides is 47.8 degrees Celsius and 47.3 degrees Celsius under 110 volts, 60 Hz. The highest temperature is only 50 degrees Celsius, which can prove its high efficiency. We also tested the full load performance of this charger during the temperature test. The voltage and current curves are horizontal and straight during the test, without obvious fluctuations, so it's quite stable under long-term full load conditions. Although this charger adopts a traditional design, it performs better than the compact 35 watts charger in terms of temperature, ripple, and conversion efficiency. And this charger is equipped with the detachable prongs, which is very convenient. But it's up to you to choose the most suitable one. Okay, that's all for today's video. If you like this video, please drop a like, leave your comments, and subscribe to us. And I'll catch you guys in the next video. Bye!